All right, so we left off yesterday. We had one slide left in section 1.5, which was on zeros of a function. And what zeros of a function are is it's a number you can plug into a function, and the answer is 0. So let's say I had that function. What number could I plug in for x and get 0? Yeah? Yep, -2. So -2 would be called the 0 of the function. So it's a number that you can plug in for x, and when you do, you get 0 for y. Now, some functions have more than one 0. Depends on the kind of function. Visually, a 0 is where the graph crosses the x-axis. Think about it. If you plug in -2 for x, you get 0 for y. The point -2, 0 is on that graph, and if you plot it, you'd be right on the x-axis, 2 units to the left of the origin. Now, if you have a parabola shape, it is possible that a parabola shape, which comes from a quadratic, could cross the x-axis no times. There's no crossing of the x-axis. It could cross one time. We actually don't even really call it crossing. It's kind of like it comes down, touches the axis, and then bounces back up. Or it could cross twice. Wherever the graph crosses, that's called the 0. And for a quadratic, there is a very quick way to not figure out what the zeros are, but how many there are. Does anybody recognize this? It's not the whole thing. It's like something. Yeah?
Isn't it called the discriminant?
It's called the discriminant, and it's the part of the quadratic formula that's under the square root. So what we're basically going to look at is 3 cases. When the square root comes out positive, when it comes out negative, and when it comes out to exactly the number 0. If the square root comes out negative, the b squared minus 4ac, you'd be trying to take the square root of a negative number, which would be imaginary. So when b squared minus 4ac is less than 0, you will never have any roots. You might have complex roots and imaginary, but that's later on. Okay, so you wouldn't have any real roots. If the b squared minus 4ac comes out to exactly 0, then that would be the kind of quadratic that touches the x-axis once, goes back up. And if the b squared minus 4ac is greater than 0, then you would get 2 roots. That's because you'd be taking the square root of a positive number, and there's 2 answers. Okay. Any questions on that? That's really the last thing I wanted to mention.
So, no zeros would mean like no answers, right?
It would mean no real. Well, yeah. There's no zeros. There are no real answers to the problem.
Okay.
There could be imaginary.
Yeah.
Yeah. But again, we're not doing imaginaries yet. Other questions on them? Okay. So. Okay, so that was the last part. There won't be any question from the homework on the zeros because we're going to do that in many other sections. So we'll have a chance to have homework on finding zeros. All right, so what we're going to do in 1.6 is look at what's called composition. It's a way you can combine 2 functions together, and some other operations besides composition, like adding, subtracting, multiplying, dividing, that we can use to combine functions together. And what we're going to focus on is trying to find domain and range. So again, that's basically what I just said we're going to do today. We're going to take two functions and we're going to combine them together in different ways. You don't have to write that down necessarily. The way I'm going to start to do it with you is addition, subtraction, multiplication, and division. After we do it that way, then we'll get into composition. Okay, so to combine two functions together, they'll give you two functions to start with, and then they'll tell you how they want you to combine them. If you're combining functions that have like terms, then you combine them. If they don't have like terms, well, then you can't really combine it and simplify it. You just write it the best you can. So an example of things you could combine. Let's say like f of x was 3x and g of x was 5x. And I said, what's f of x plus g of x? Tell me what that would be if you combine them by adding. Yeah? Yeah, it would be 8x. That would be the function you get, because they're like terms. Here, I don't have any like terms. I have x squared, and I have the square root of x plus 1. So what do you think it would look like when I add these two functions together and show you what's under the gray box?
It's going to be a little bit chaotic at first.
Yep. It's just x squared plus the square root of x plus 1. You can't do anything with it. It's as simple as it gets. So that's a new function from the original two combined by adding them. How about f of x divided by g of x?
It would look like that, except it'll be a fraction.
Yeah, it would be very similar, except it'd be a fraction. And in Algebra 2, you probably talked about square roots, and there's something you're not supposed to do with square roots, and we've actually done it there. Does anybody remember yet?
How it has the denominator?
Yeah, you're not supposed to leave it as the denominator, so we can fix it by multiplying the top and the bottom by the square root that's in the bottom. What do you get in the bottom if you multiply the square root of x plus 1 times the square root of x plus 1? Yeah.
You'd get x plus 1.
You get x plus 1. And in the top, it's x squared times the square root of x plus 1. There's nothing you can do.
So it's essentially PEMDAS, right?
What do you mean?
Like the order of operations? Like parentheses, exponents, multiplication, division, addition, subtraction?
So we didn't have any parentheses or really exponents we were combining here.
Yeah, that's just what I was taught.
Okay. So it's basically just putting the two functions together, and it's more like combining like terms if you can.
Yeah.
If you can't, then you don't,
Okay.
and you just leave it like that. Yep.
Why can't you cancel the x squared and the x in the bottom? Like, why can't you make the top an x and then the one in the bottom goes away?
Because
Top and the bottom are x.
so you can only cancel something if it's a factor that appears everywhere. So like if you had a 4 times a 12 divided by a 4 plus 1, you can't really cancel those 4s. Because if you wanted to cancel a 4, you'd have to divide this, 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 and that by 4 to cancel out a 4. The problem is this term doesn't have an x in it. So you can cancel an x from the top and from here, but not from here.
Okay. But it's only because it's an addition sign?
Yes, if it wasn't an addition sign, then you could do it.
Alright.
If that was a multiplication sign, then we wouldn't even really need times 1 because it wouldn't change anything. And then you'd have x squared over x, which would reduce to x over, and the x would cancel. But yeah, if it wasn't, it's the addition that messes that up. So keep that in mind. We want to cancel out, and you have an addition sign, that breaks it into different terms, and you have to be able to cancel it from both of the terms. So what would the domain be when you combine two functions together and get a new function? Well, it's basically the overlap of the original domains. So think of this as all the numbers that belong to the original function. Think of that as all the numbers that belong to the second function. The domain of the new one is that. It's all numbers that belong to the domain of both a and b, or in this case, f of x and g of x. Now, the only thing you have to be careful with is if you combine two functions using division, you may end up creating a fraction where you didn't have one before. And if you do create a fraction, you have to make sure that you never plug in a number that would cause you to divide by 0. We also want to make sure we don't take the square root of a negative. Those are the two things that I keep mentioning all year when we talk about domain. Don't divide by 0, and do not take the square root of a negative. If any one of those things could happen, you need to tell me numbers I can use so it does not happen. Okay. Let's try some examples. So it wants me to take these two functions, and I'm going to combine them together in some way. Before I combine them, it's helpful if we know the domains we're starting with. Now, is either one of these functions one of the two things I keep mentioning that you have to be careful about? Yeah?
They're both square root.
They're both square roots, so what do we have to be careful about?
We have to make sure that the x does not make it so it's equal to less than 0. It can be equal to 0 or anything above it.
Yes, we have to make sure that what we plug in for x keeps this at 0 and up. So negative 10 is not a number you could plug in for x. So I don't want to know what you can't plug in, I want to know what you can. What numbers could you plug in for x to make sure that this is 0 or higher?
All positive numbers.
You could do negative 1. That would be okay. Because negative 1 plus 3 is 2.
All real numbers that are greater than negative 3.
Greater than or equal to. So the lowest value we could pick is negative 3. The highest value you could pick is as high as you want to go. Can you include negative 3 in what you pick? Yes. Can you include infinity? No, we can't reach infinity. So that's the domain of your original. f of x. What's the domain of g of x? What numbers could we pick for that? Yep.
2 and anything above that.
So you can include 2?
Yes.
Yes, you can.
Include 2, and it goes to infinity.
And anything above. Yep. Okay, so now we know the domain of each of the originals. Let's combine them first by adding. Again, they're not like terms. Like terms would be something like this. Those are like terms. If you took 2 square roots of x and 3 square roots of x and you add them together, you have 5 square roots of x. What makes these unlike terms is the radicands are different. So you can't combine them. You're just going to have to write what you get. So Jack, what would you get when you add these functions together?
I'm kind of lost.
So we're going to combine these two functions together. and we're going to by adding them. But they're not like terms, so there's nothing to combine once you
So
write that
would
down.
it just be the square root of x plus 3 plus the square root of x minus 2?
Yeah. So that's a new function. If you were to graph this on the calculator, it would look different than the originals. And we created the new function by adding the 2 that we started with. Now, what would be the domain? So the domain has to be all the numbers that would work in this one, and this has to work in both. So you might find a number like 0. It might work here, but then 0 doesn't work here. So 0 is no good. Yep.
You're gonna equal then 2?
Yeah.
Up to infinity.
Yep. It's 2 to infinity. So the domain of the top one, if you want to think of it like on a number line, is everything from -3 and up. The domain of the bottom one is everything from 2 and up. So the question is, where's the overlap? 2 and up. That's your overlap. What's up? Right, let's try this one. I'm not worried if we leave a square root in the bottom. I don't think. Well, let's just do it, and then we'll see whether we fix it. How would you write f of x divided by g of x? Well, will it?
So you put x plus 3 square root
Yep, square root of x plus 3.
on top, and then square root of x minus 2.
Square root of x minus 2. Yeah, I'm not worried about fixing the square root. We'll just leave it like that. So I want to know what the domain is this time. Yep.
The domain can be, it's the same as last time, but this time it cannot be equal to 2.
Why can't it be equal to 2?
Because if it's equal to 2, then the bottom will be 0, which we don't want.
So the domain here is still the overlap of the 2, but we created a fraction. Fractions have one other thing you have to be careful about, and you can't divide by 0. So that means you can pick numbers as low as 2, as high as infinity, but you cannot include 2, and you can't include infinity. That's your domain this time. Is there any question on the difference between the domain in the first one and the second one? So it's a small difference, but if you accidentally put the bracket instead of parenthesis here, it would be wrong, because that's not the right domain. Okay. I don't. Okay, yeah, we could graph it, sure. All right, let's graph it. So we're going to type in what we just did. Bless you. So square root of x plus 3. Make sure you hit the right arrow now to get outside of that square root symbol, because now I want a new square root, and then x minus 2. So I don't know why I'm asking for the domain again, because I already did the domain, unless it's a different problem. Hold on. It's a different problem. Okay. So I'll take that back. Let's type this in instead. Absolute value of x. So that's math and then number. And the first option is absolute value and x. Oh, let's write it out. Oh, why did I do that? Divided by x. So it's f of x divided by g of x. When I write it out on paper, I probably wouldn't write it horizontal like that. I would write it like you see here. absolute value of x divided by x. Well, let's start with the domain. Is there any number that you are not allowed to plug in for x here?
0.
Yeah, you can't plug in 0. Is there anything else? I don't think there's anything else. No?
With this equation, the only one that we can't have is 0.
Yeah.
Because the absolute value on the top, it kind of doesn't matter whether it's
So yeah, the top can be anything. It's just the bottom can't be 0. So can you pick numbers lower than 0? Can you pick numbers higher than 0? All right, you just can't pick 0. So you can go as low as you want to pick, up to 0, but don't include 0. Or you can pick a number from 0, but don't include 0, as high as you want to go. That's how you write all numbers except 0. So it's everything below 0 and everything above 0. And sometimes in place of the word or, you'll see this symbol. That symbol in math means or. It technically means union, which is like or. So that's your domain. And now let's think about the range. What would you get if you plug in 5 into what I just put a box around? Yeah?
Well, it would be 1.
1.
The range can only be between 1 and -1. Those are the only 2 values. There's nothing else.
Right. There are only 2 values you will get when you plug numbers in for x. If you plug in a positive number for x, the answer will always come out to 1. If you plug in a negative number for x, it will always come out to -1. So this time the range is only 2 numbers. When you only have 2 numbers in the range, you can list every single number. There's only 2. So the way we list them all is we use this symbol, which means what I'm about to write down now is a set of numbers. And the set of numbers in the range is -1 and +1. When you have a set of numbers that goes to infinity, it's impossible to list every single number. You can't. So that's why we have to do it as an interval. But when you can list every number, we can write it as a set. So if its set of numbers is -1 and 1, and if you hit graph, you're going to see that when x is a negative value, you get -1. And when x is a positive value, you get positive. So it's a range that only has 2 values in it. That's pretty rare, but it happened here. Any question on that? Okay, let's create another type. Learn how to combine functions a different way, and this is called composition. Does anyone remember composition?
Oh yes, they were the most annoying thing last year when I had to do them. I basically, I kept having to look up how to do them.
Okay, well hopefully I can explain how to do them simply. Yeah.
It's like f of g of x.
Yeah, it's like f of g of x. And the idea is you plug one function into another function. That's composition. So let me show you an example. Here's the notation. When you see a parenthesis, you pronounce that as the word of. So this is g of f of x. Well, if I wanted to find g of 2, I would plug 2 into function g. If I wanted to find g of 4, I would plug 4 into function g. If I want to find g of f of x, I'm going to plug f of x into function g, just like I would plug a number. It's the same idea. Okay. So what is f of x here? Yep.
F of x is x squared plus 3.
So I want to find g of f of x. That's what I want to do. Plug x squared plus 3 into g. So take this and fill it in for the variable in g. If you did that, what would you get?
The square root of x squared plus 3.
Yep. And remember that square and square root don't cancel. We talked a little bit about something different earlier, the plus sign messing up that kind of thing. Well, it messes that up here too. So you cannot simplify that any more than it is.
What if it was 9?
Well, if you had something like the square root of
Every square.
9x squared, you could write 3x. But if you have addition or subtraction in there, no. You cannot apply a square root to individual terms. You can only apply a square root to a factor, which means a product. Let's try it the other way. F of g of x. This means f of, and now look up g of x. Square root of x. So now, in the f function, you're going to replace all the variables with a square root of x. Let's just do that first, even if it does simplify. Just replace the variable with a square root of x, and then we'll see if we can simplify it. Yep.
It would be the square root of x squared plus 3.
Square root of x squared plus 3. Now that does simplify. What's the square root of x squared? Yep. Just x. So you get x plus 3. Now, you might think, oh, well, if I ask what the domain is, it's just adding 3 to a number. So you can add 3 to any number you want. Yes, that's true. But you have to think about where this came from. And were there any restrictions on the formulas that it came from? If there were, we need to think about that. And I'm going to show you how to think about that right now. Yeah.
So could it just be like a parenthesis and a 0?
So yes, the domain in this problem would technically be everything from 0, including 0, and up. And I'll show you why. Okay, I guess I'll show you this, but I never write it this way. You might see that notation in the book. They put a G and then a circle and then an F. It means this. I always use this. Okay, you won't ever see me write that like on a test. Yeah, just like in the homework, you might see G, circle, and then an F. But as long as you understand that way, it's the same. So how do you find the domain when you compose two functions together? Well, it's 2 steps. So first, in my head, I think, okay, the domain is all real numbers. I start with that. And then, from that, I eliminate any values that do not appear in the domain of the inside function. So it's kind of like a filter. So I start with everything, and I filter out values that are not part of the domain of the inside function. What's the inside function? Well, in this problem, f of x is the inside function. In this problem, g of x is the inside function. So you eliminate any values that are not in the domain of the inside function. Step 2 is now you look at your final answer. And you eliminate any values that are not in the domain of the final answer. When would you have to eliminate values in the domain of the final answer? If your final answer had a fraction with a variable on the bottom, or your final answer had a square root in it. If your final answer doesn't have either one of those two things, like that, then there are no additional values that get eliminated from step 2. The only thing you'd have to consider in a problem like that is step 1.
Sorry.
Okay, so I see a square root here, so we got to be careful about things depending on how we combine them together. So the directions could ask you to add them, subtract them, multiply them, divide them, or compose them. This is an example that's numeric. You're just going to practice plugging in a number and trying to get the answer. So when you have to do it with a number, start on the inside and work your way out. Start by finding g of 9. Don't even do anything with f. Someone just tell me what's the function that's g? What's the formula for it? Is that square root of x? And what number do they want me to fill in to that formula?
9.
They want me to fill in 9. So the first part of this says to take the square root of 9. And you get 3. Now they want me to plug 3 into f. What would I get if I filled in 3 for f now? Yeah.
Sorry, 2 or 4.
4. So you're going to fill that 3 in right there. And you get 4.
Wait, it could. This one has 2 answers.
Well,
Because one square root.
if they put that symbol in front of it, plus or minus, then we would have to do both. Whenever you just write that symbol by itself, it strictly means positive answer. But that's a good point. That can happen with square roots, but doesn't happen here.
How would you find a second answer that just negative 3?
How would you do what?
Find the other answer if it was.
If there was a plus or minus in front?
Yeah.
So you'd plug in 3 to function f, and then you'd plug negative 3 into function f. Yep. All right, now let's do composition. I like to write it first. So f of, look up what g of x is. Square root of x. And I'll do this one too. G of, and then look up what f of x is. X plus 1. To me, that helps it be a little bit less abstract because now I can actually see a formula that I'm plugging in. So plug in square root of x into the f formula. What will it look like if we do that? Plug square root of x in for the letter in the f formula. Is that?
The square root of x plus 1.
Yeah. Like this. Yeah, you definitely want to make sure that plus 1 is outside the square root. This time. Now, plug x plus 1 into the g formula. What's that going to look like? Plug x plus 1 into the g. Yeah.
It would be the same except the square root goes over both the numbers there, where it's square root of x and 1.
Right. It's going to be the square root of that whole thing. So it's just a little bit of a change in how long you draw that square root bar, but it completely changes the answer. Questions on it? I have a lot. I'm not going to go through every single one. In fact, I'm going to shorten this one a little. Which way do I want to do it? Let's do f of g of x. So let's just do the second way. F of g of x. Always a little more interesting. And find the domain. Okay. Okay, so let's start out. What's g of x? Yeah, right. Square root of x. And now we're going to plug that in to the f formula. I don't want you to simplify anything right away. I just want you to change the variable in the f formula to square root of x. So what would you get unsimplified if you did that? Well, Jacob, what would you get?
Square root of x squared minus 1.
Perfect. Square root of x squared minus 1. Now that simplifies. What do you get when you do the square root of x squared? Just x. So if all you do is look at the final answer, you might say, oh, domain is all real numbers. You can subtract 1 from any number you want. There's no square root. There's no divided by a letter. But that's not exactly how you find the domain. First, eliminate any values that were not part of the inside function. Here's the inside function. Are there any values that we have to be careful we don't use for x, where I'm pointing? Yeah, dude. Yeah, we can't use negative numbers. We gotta already eliminate all the negative numbers and just restrict ourselves to positives. Now look at the final answer. Is there anything you can't subtract 1 from? No. So there is no additional restriction that comes from this. The only restriction on the domain here comes from the original inside function, which is limited to numbers 0 and up. Just like that. Any question on that? So it's not that hard. I know sometimes people have a hard time with domain of composition functions, but as long as you follow those 2 steps, it really makes it very systematic how you do it. You don't have to guess and try to figure it out. You just follow step 1, follow step 2. That's it. Now for range, well, I use the graphing calculator. That's the easiest way to see the range. But what you're really doing when you try to find the range of a function is you're thinking about, okay, I know the domain is every number 0 and up. If I plug numbers that are 0 and up in right here, how high and low will my answers go? That's the range. So what's the lowest answer you could ever get by plugging in a number from the domain? You can fill in any number right here in right there. Yep.
-1 is the lowest.
-1 is the lowest answer you will ever get that comes out of that box. And what's the highest answer you would get? Yeah. Infinity. So the range there is -1 to infinity. The graph makes it a lot easier to figure that out. So you find your domain, and then you see what kind of answers do you get from your formula when you fill the numbers from the domain into it. Again, the graph is how I'm going to do that most of the time. Because range can get tricky. Can be hard to figure out. That last one was easy. They're not all that easy. Let's again just do this one way. We don't have to do it both. Doesn't really matter. You tell me. You want to do the first way or the second way? Well, Lily, you pick.
First one.
You want to do the first one? Okay. So Lily doesn't like the second one. We're not going to do it. Let's do the first one. So find g of f of x. Michael, what's f of x in this case?
The square root of x.
Square root of x. And Mia, if I change the variable in g to square root of x, what would it look like? Yep, minus 3 under the root or outside? Yep. Okay, so there's your composition. Now let's look at the domain. Start with the inside function. Is there any restriction on what kind of numbers you can take the square root of? Yeah. It cannot be a negative. So that means we have to pick 0 and higher. Now look at the final answer. Is there any kind of numbers you can't take the square root of? Yeah.
It's the same as last time, meaning any negative numbers you can't do.
Right.
So it's the exact same restriction.
Yeah, you get a restriction in both parts, but it's the exact same restriction. The inside function says you need to pick numbers 0 and higher. The final answer says you need to pick numbers 0 and higher. So that's your domain. 0 or higher. Range. Well, you might be able to figure this one out, but we can sketch it. So let's type in the square root of x minus 3. And we're looking for how high and low this square root function would go. Remember, square root function is a sideways parabola. So what's the lowest it looks like it goes? And then what about the highest? Well, Anna, what do you think?
The lowest is -3 and the highest is
Yep. And will you reach -3? Yeah, you sure will. If you plug in 0 for x, you get the square root of 0 minus 3 is -3. Yep. So there's your domain and your range. So I think if you use the calculator, it's not that bad to find the range. Any question on that? Yeah. Yeah. What am I getting at here? Oh, okay. So, when you put, what kind of symbol in a problem causes a reflection? We talked about this with transformations. A negative. Now, we mostly talked about a vertical reflection yesterday. That's because when you reflect a parabola vertically, it's easy to see. It goes from opening up to opening down. When you reflect a parabola that's on the y-axis horizontally, you can't even tell you did it. So we didn't really talk about reflecting in the y-axis. But that's what I want you to write down. If you take and make the x a negative in a problem, that will cause an image to be reflected over the y-axis. Let's try it. Take a problem and change the x to a negative x. Let's do square root negative x plus 3, or minus 3. Now hit graph and let's see how they look. It's a mirror image over the y-axis.
Why doesn't it screwed up, like when you have a negative x in the square root.
Because now the domain here would be all negative numbers. Because if you take like plug in -2, you'd have -2.
Oh yeah.
And then it would become a positive under the square root. So now the domain in the bottom one is all negative numbers because then the negative cancels the negative. So negative on the inside of the square root causes a horizontal reflection. Negative on the outside of the square root would be a vertical reflection. So you can reflect something that's a vertical in black, and then in red is a horizontal. I'm just focusing really on the horizontal here.
And then if you do both of them, let's say it's vertical and horizontal.
Yes, if you put the negative on the inside and the outside, you get both reflections at the same time. Yep. So I think we're just about there. So we looked at transformations as they applied to quadratics, but I told you those transformations apply to anything. It doesn't matter if you use a quadratic, square root, anything. So I'm going to make a chart of transformations, and it's going to generalize what we learned yesterday to any function that we've studied all year. I'm going to show you the one on the right, and I'm going to see if you can tell me the name of the transformation on the left. First, I'm waiting. Does anyone still need to copy down the chalkboard? Okay, so we're just generalizing what we learned yesterday. When you multiply by a number in front, think of like yesterday, x squared, 3x squared. What did the 3 do? You multiply by a number in front.
Stretch.
What kind of stretch?
Good.
Or shrink. It depends if it's greater than 1 or less than 1. So when you multiply by a number in front of a function, it will always vertically stretch and shrink. Always. How about if you add or subtract a number on the end of a function? And what's going to come next is the inside. There's a difference. If you add or subtract on the end, yeah, it'll shift it up or down. So what does that mean? Well, square root of x. Say that was the original function we were studying. That's a shift up 3. Adding or subtracting a number onto the end always shifts up and down. I did them together because it's pretty straightforward. Positive is up, negative is down. What about adding inside the parentheses? Which way does that shift? Ron? Which way is which? Positive would be to the...
Positive would be to the left, and negative would be to the right.
And negative is to the right. Yep. Now, I just went over this. If you put a negative in front of the function, so this is what we did yesterday, like y equals x squared, or y equals 3x squared, and y equals negative 3x squared. What kind of reflection do you get when the negative is in front of the whole thing? Yeah? It's a reflection over the x-axis, which is a vertical reflection. And what about when you put the negative inside the function and you're filling in negative x for a variable? Yep.
That's a reflection over the y-axis.
Yep. That's a horizontal reflection or a reflection over the y-axis. Okay, so the last question I'm going to do is more of a visual. It's not a formula, but it's going to be transformations. And we're going to draw it. It's going to be like a shape. Let me give people a second to copy down the last couple. Okay, there's your shape. You want to know specifically, it has almost like 3 vertices, one at -2, 0, one at 0, 2, and one at 4, 0. And I'm going to transform that shape. So I'm going to see if you really know what these transformations mean.
You did a lot of this in geometry.
What's that?
You did a lot of this in geometry.
Yeah, the transformations.
Yeah.
So yeah, it should be pretty easy right now. We're going to call this graph f of x. I want you to find that. So there's some things happening to it. I think I'm just going to copy that down. So let me go like this. Here, here, here. That was a curve. That was straight. And that was straight. We talked about the order of operations yesterday when we do transformations. What number are we going to focus on first here? The 2, the 1, or the -3? Yeah? The 1. And I'll color code this. What's the 1 going to do? It's adding a number inside the parentheses, so you can scroll back up if you need it.
Shift it 1 to the left.
It's going to shift it 1 to the left. So I'm going to draw it right on top of it. I'm just going to take every dot and move them 1 left. There's my first. What's the next number I look at? The 2 or the -3? Which one?
I think it's 2.
It's the 2. And what's the 2 going to do?
Vertical stretch.
Vertical stretch. So if you stretch something vertically, which values change in the coordinate? The x or the y?
No.
The y's change. And how are the y's changing here? What's the factor?
It's factor 2, so it's double.
They're doubling. All the y values in that picture need to be doubled. The x values need to stay the same. So where would this point end up if I double its y value?
It wouldn't change.
Wouldn't move. Where would this one end up if I double its y value?
It
would end
go
up at-
to
Yep, end up at 4. And how about the y value of the point all the way on the right?
no.
Same thing. So there is a vertical stretch by a factor of 2.
So when we vertical stretch by factor 2, the thing in parentheses will be multiplied by that number.
When it's a vertical stretch, the y value is multiplied by that number.
And the y value with that. Okay, so all y values.
Now, how about the -3? Yeah, it's going to shift it 3 units down. So take every point. 3. And shift it 3 units down, if I did that right. That's the picture I'm looking for. It's good. Okay, so no formula, more of just an image that you're applying transformations to. So you'll have 1 or 2 like that in the homework tonight. And that, I think, finishes chapter 1. Okay, so that's the homework for tonight. Okay, on page 66. And we'll take a look at that first thing tomorrow. Remember, tomorrow will be the last day of new material. And Friday we have our first test on everything from this week. Okay, just going to focus on this week.